A couple months ago, I bought my first Bambu Lab printer, P1S. I was surprised by the printing speed and the printing quality of that printer. It has been a great tool to help me design prototype with my other printers. Because of its high-speed printing, I could use it to verify some ideas and get a finished part out without waiting overnight. More importantly, I could make design improvements and some feature changes, and verify the update with actual printed part within a very short period of time. It greatly improved my workflow and my productivity. Since then, I have bought more Bambu Lab printers to fit my workflow. Until a couple of weeks ago, I finally got all the Bambu Lab current models in my printer collection. I think now, it's time to make another printer comparison video. My name is Lau, you're watching at Printer Face to Face. I have made review videos for all these three printers. It covered more information on those videos. If you would like to check them out, the link is attached in the description below. We will briefly cover some technical detail things of all three printers in this video, running some test print and do a comparison, and summarize with the final thought. All the opinions are subjective and very personal biased. It is all based on my personal perspective from experience how I use those printers on my daily routine. With that being said, let's get started. Let's talk about money first. From the least expensive one, the P1P, it is currently sold at $599 MSRP. P1S by itself is $699, $949 with the AMS combo. X1 Carbon $1,199 MSRP, $1,449 with AMS combo. This list price is in US dollars, without tax and shipping. We can see they are targeting a different potential customer with a different price and feature offering. Good thing they didn't name it P1P Thai, P1P Super, P1P Thai Super. Very obvious. On my left hand side, this bare bone machine P1P comes with the lowest price tag of all three printers. P1S stays in the middle, looks very low profile with the old blacked out color. X1 Carbon looks a bit more of premium machine. Under its cover, these three machines share the same basic structure. They all have the same spot weld steel frame to ensure the frame rigidity and stability. P1S and X1 Carbon have a fully enclosure printing space. P1S uses industrial molding plastic side panels and glass front door. X1 Carbon uses aluminum side panels and glass front door. Bambu Lab states X1 Carbon could reach 60 Celsius chamber temperature with passive heating from the printer bed and nozzle. I can't find information regarding the P1S. This chamber temperature will greatly improve the printing quality for ABS, polycarbonate, nylon carbon fiber, and other high temperature filament. It will also reduce the warping and helping the part to stay on the build plate. P1P very much just rely on the environment temperature. Within the frame, all three printers share identical motion system. They are called XY structure machine with a two 10mm carbon fiber rod on the x-axis to reduce the weight and moving momentum. There is one 8mm linear rod on each side of the y-axis. Two stepper motor to control both x and y-axis motion. Extruder move x and y-axis on a stationary plane. As plastic fused on the build plate, the printer bed is moving downward on the z-axis. There are a total of 3 lead screws on the z-axis to control by one stepper motor and synchronize with one bell. Each lead screw cannot move individually. The printer will automatically perform some self-tests to ensure it stays in the one plane of all three corners. The extruder on all three models look very similar. Well, it is identical on P1S and P1P, but X1 Carbon has one fancy LED light on the front cover. Too bad there's no RGB lighting to boost the performance. They are all full metal hot end that could reach 300 Celsius maximum temperature. The main feature difference is that X1 Carbon comes with a hardened extruder gear and nozzle. You can also upgrade the stock extruder and nozzle for both P1P and P1S without too much of cost. Well, it is more appropriate to call hot end assemble. since the nozzle and the hot end are press-fit together. You cannot replace the nozzle by itself. I was quite surprised at the durability of the standard stainless nozzle. My first P1S still had the stock nozzle after running near 900 hours of a print. It has been running some wood filament, glow in the dark filament, and some sparkler filament occasionally. Even one time the wood filament have completely clogged the nozzle and the bake within the nozzle badly. It took a while, but I managed to get it clean and return to work. So the hot end nozzle assemble might be cost a bit more initially, but for the long run, it will actually save you money. Bambu Lab stated that all three printers could reach 20,000 mm per second square acceleration and a 500 mm per second maximum two-head moving speed, just like every other brand stated on their high-speed printer. In reality, you are barely able to print with that speed. I normally just leave all the speed setting default from the slicer, 10,000 mm per second square acceleration and a 200 to 300 mm per second printing speed on walls and infills. I can potentially increase the printing speed to get less printing hours, but a lot of cases, increase the speed will require a lot of fine-tune for each models and filaments if you want to still maintain a good printing quality. I'd rather leave it as it, and it works for most of the models and the filament from my experience. It also keeps a good balance of printing speed, printing quality, comparability, and the machine life. All these printers have identical printing volume, 256 mm square and 256 mm height. P1P and P1S come with a two-side PEI texture sheet, and X1 Carbon come with a two-sided cool plate and engineer plate. I personally prefer PEI build plate as it works great for most of filament and generally does not require glue stick to let the part stick on the build plate. On the other hand, X1 Carbon build plate cool plate is designed for PLA. It works great with a PLA without glue stick, but when you're trying to print some PETG and PLA carbon fiber on the engineered plate side, the first layer adhesion may not be that well without a glue stick. With glue stick, it worked extremely well. I got a perfect first layer adhesion with no warping, not even with those harder print filament like nylon and polycarbonate. But I just don't like the glue stick mark that left on the build plate and the parts. You will need to also wash it occasionally. It is just a lot of extra work compared to the PEI sheet, which I can get over with wiping with isopropyl alcohol before printing. Both P1P and P1S could reach 100 Celsius maximum bed temperature. X1 Carbon could reach 120 Celsius maximum temperature on 110 volt region. The additional 10 to 20 Celsius make it more desirable for those higher temperature filaments. P1P has stripped away a lot of features compared to the P1S and X1 Carbon to reduce the production cost. Besides, there's no enclosure on the P1P, there's no chamber fan, there's no auxiliary part cooling fan, control board fan, active carbon filter, cable chain, and all those features are removed compared to P1S and X1 Carbon. Compared to the P series, there's a lot of additional features on the X1 Carbon. The most obvious one is that micro ladder and all the features based on the micro ladder. Integrate with our algorithm and neural network process unit, feature like first layer detection, spaghetti failure detection, flow rate calibration, build plate recognition, and build plate location detection all come with X1 Carbon. At the same time, X1 Carbon comes with a bigger size 5-inch touchscreen combined with additional quad-core processor. X1 Carbon is able to integrate a lot more advanced features on the touchscreen because of the chip upgrade. Besides those basic features to control the printer, there are a lot more features you can change from the touchscreen. There is more information present, additional features that P3 does not come with. You can also turn X1 Carbon to land mode only if you are concerned about the data privacy and the cybersecurity things related to the cloud at home. The chamber camera is also upgraded to 1080p with a better resolution and response speed from a slicer and a mobile app. You could also directly access the file stored on the printer from the slicer on the X1 Carbon. For someone interested, here's a noise level for 3 printers. I think it very much covers all the features specs different between all 3 models. As mentioned earlier, Bambu Lab stated that they have all the same printing speed and acceleration potential. The hardware on motion system is also identical, besides the upgrades hot-end extruder gear and a faster processor speed and the flow rate calibration feature on the X1 Carbon. How much does those features gonna help with the X1 Carbon in terms of printing speed and printing quality? We are going to find out on the next segment. Because I only have one single sample for all 3 printers, the printing test part cannot be carried out very thoroughly. The variable among individual machines may have a greater impact to the test result. So, rather than running those sample tests and telling you which model is faster or which model is better, I would like to verify how much better each printer could handle different filament. As I mentioned above, the hardware upgrade on X1 Carbon, the bed temperature is higher, the process heating chamber is better for high temperature filament. I want to verify that how much better in a more measurable way. Also, I want to confirm my statement that you could still use a P1P and P1S to print some exotic filament occasionally. Regardless those tear and wear issue, I want to confirm and prove you that that's doable. We are going to run some general test model. We will next test with Bambu Lab Studio Slicer to use default profile to run some exotic filament. Let's start with the basic functional test print with the PLA filament. Starting with the benchy, all 3 benches are printed with 0.2mm layer height, with the default setting from Bambu Lab Studio Slicer. The printing speed setting is the same, and they all use the same Bambu Lab PLA. I will place all 3 finished prints under the same light condition and recording them with the same camera angle. I think all 3 benches looks very decent. Can you guess which bench is from which printer? All the layer finish and little detail looks good. There is barely any ringing effect. Overhand and bridging all look very decent. Next, I'll push it to the limit. We are going to use 0.24 layer height, reduce the infill to 10%, also increase the printing speed and accelerations. I orientate the benchy overhand to the auxiliary cooling fan side. In theory, P1S and X1 Carbon should get a better cooling result on the overhand and the bridging. Both P1S and X1 Carbon are printed with the front door open, and P1P itself is just open to surrounding air. I forgot to record the printing time with a stopwatch, but the print was sent to the printer at 8:29. It finished on P1S at 8:50. The printing time presented on the slicer is very close to the actual print. Notice that X1 carbon printing file was sent before the P1S, but it has a few minutes remaining printing time. It is because flow dynamic calibration and build plate recognition and other features was turned on. It takes 2 or 3 minutes longer preparation time was present on the slicer. But all three printers' actual printing time for this bench sheet is around 15 minutes. We can see the printing quality is significantly worse than the last one. The layer line is very obvious of all three print, but we don't have any overhang cooling issue at all, even for the P1P. The top finish looks identical of all three. On small pyramid area, the top layer finish on X1 carbon with the active flow calibration on looks better than the other two. Let's move to PETG filament. PETG filament generally require higher nozzle temperature compared to PLA. They are more sensitive to moisture, easy to stick on the nozzle, and more often have a stringing issue. They also require less cooling during printing. Exceed amount of cooling normally lead to bad layer adhesion for this filament. However, we are going to run this model that consists of many hollow geometry. It requires a lot of retraction during printing. You may get a good result easily with a PLA filament, but it might be very tricky to print with a PETG filament. I think we got three very similar printing results again. All three models have very small amount of stringing. Retraction performance are great for all three extruders. Continue with a more exotic filament. We are going to print this PLA-CF blend. This is one of the relatively easy printing carbon fiber blend filament. It does not require very high nozzle temperature and bed temperature. The print on X1 carbon is from my review video. There is one random debris stick on there. Other than that, all three print looks identical to me. I did not put any glue stick on the build plate for my first attempt on the P1S. No supplies, it comes off the build plate sometimes later. This nylon carbon fiber is a nylon-based filament filled with a 20% carbon fiber. It has a higher strength, higher agility, good toughness, and better wear resistance. It also comes with a few downsides. It is extremely sensitive to moisture, hard to print, does not like stay on the build plate, and very smelly during printing. All three prints have debris on the same area, where the nozzle travel back and forth on the two parameters. Other than that, all layers and the surface finish looks pretty good to me. Again, we got very much identical print from all three machines. Final thoughts of Printer Face-to-Face Episode 2. We have gone over the detailed technical specification and the comparison. You have seen the test result from all three printers. I would like to share some of my thoughts on these three printers from my personal perspective. I would like to mention that most of the potential buyers who think into Bambu Lab printers are mainly looking for a relatively easy-use machine and its performance. There might be some desirable to make mods and upgrade to their machine and make it unique, but they are mostly not looking for trickling experience, so we are going to leave aside closed source and open source and all those arguments in today's video. It is important that you need to understand Bambu Lab delivered a very good product and probably the most beginner-friendly machine in the market. However, 3D printing, this hobby itself, still requires some learning and some knowledge and skill. You don't need a PhD degree in engineer and applied science before running your 3D printers. But you need to learn some of the basic knowledge of 3D printing and learn how to use your machines. You could start first enjoying 3D printing and learning as your 3D printing journey goes. You'll get failure print, damage your machine potentially, get frustrated, but that's almost all the learning process goes like. But the amazing part for 3D printing is that we have a very active community support from other people. Your question will get answered, People will help you out with your issues, as long as you don't hesitate to do the research by yourself and asking questions. Back to our topic. All three machines are in line and deliver a very easy start experience. The initial setup is relatively fast and easy. There's no whole lot of assembly needed. There's no calibration of moving parts before printing. Bambu Lab machine and its ecosystem, including slicer, mobile app, and model website, will give you a great experience on a daily basis too. Machines are relatively easy to use and very reliable. I saw a post the other day. A guy posted his X1 carbon with a 9,000 plus hour, and the machine only replaced those tear and wear parts. Regular maintenance is the key to keep the machine in good shape and happy. I would like to quote his post here. All these three machines will run some self-calibration when you first set it up. It will basically get everything ready for you. You don't need to do manually bed leveling, and there is no adjustment for the Z-height offset thing. P1S very much an enclosure version of a P1P. X1 carbon offer a lot of additional features like the first layer detection and spaghetti detection for further reduce the possible of printing failure and save your filament waste. All these technology blend well in the background and help you out with your experience. As we tested before, there is basically no difference between these three machines in terms of printing speed and printing quality. P1S and X1 carbon offers a passive heating chamber for some higher temperature filament, and X1 carbon with a harder nozzle and extruder gear for running those nylon blend filament to prevent exceed amount of tear and wears. We also have confirmed that P-Series is able to prefer those printing occasionally. Which one is right for you? It's based on what filament you are going to print the most and your budget from money perspective. There's nothing wrong to go fully load X1 carbon. But when you look at the price difference between P1P and P1S and how much it costs to upgrade the enclosure kit, I think it's almost make no sense to me to go for a P1P. The $100 price increase on a P1S is worth every penny. The enclosure not only offering a capability to printing higher temperature filament, but also help you out to get more stable ambient temperature during printing. This could be very handy if you are putting a printer on the garage, and very practical during the winter time. The enclosure could also prevent the dust and other dirt getting to the moving part. If you have a cat and dog at home, the enclosure is gonna save a lot of maintenance work for you. As far as the big price gap between P1S and the X1 carbon is concerned, it really depends on if you are going to print those exotic filament daily. Bambu Lab offers hardened gear and hardened extruder with a relatively affordable cost. So you could technically upgrade your P1S to better machine to print those filament. I think the main difference is that those added feature and the 5-inch touchscreen. A lot of people love to have those bigger touchscreen, but from my daily routine, I'm very much sending the printing profile from my slicer on my PC. I rarely use a touchscreen. I also have some feature turned off just because they take longer before every single print job. So all those features are nice to have, but not to the point it's necessary, in my opinion. With that being said, I think the P1S is the best bet with the price and the value. Let me know what you guys think in the comment section below. Which one is the one you are going for? Thank you guys for watching. I'll see you next video. They are Core XY machine with the two. They are all full metal hot end that could